Okay, so let's talk about the parabola. Here's the definition of a parabola. The parabola is a set of all points in the xy plane equidistant from a fixed line called the directrix and a fixed point that's not on the line called the focus. So let me go back. It is the set of all points in the xy plane. We spoke about that before, right? That's that sheet of paper that like goes out in all directions, so it's like a thin layer of the atmosphere. Equidistant means same distance, right? Equa is short for equal distance. So equal distance from a fixed line called the directrix and a fixed point called the focus that's not on that line. So here's what it's telling us. Let's take a look. If I want a point in between the focus and directrix, it needs to be the same distance away from the directrix as it is from the focus. You with me? And if I find another point that's the same distance away from the focus as it is from the directrix, there's another point. And let me get even another point over here. This would be the same distance away. And I could keep going. And when I connect these points that are the same distance away from the focus as it is from the directrix, I have created a parabola when I connect the dots. You with me? Okay, so this is the definition of how a directrix comes, or pardon me, how a parabola actually comes about. Now, we have two kinds of parabolas. So the parabolas that we've been speaking about are the parabolas that go up and down. Agreed? And then we have other parabolas, which some of you may be aware of, that go left and right. So here's the deal. I'm going to talk about the standard form of each one because there's actually two different sets of criteria, shall I say. So hang in there a second. By the way, remember what that line is that goes right through the middle of a parabola? Do you remember what we called it? Yeah, that's called the axis of symmetry, isn't it? Or line of symmetry, whichever author you are looking at. So it's going to be interesting when I write this title up because it's another word for or another phrase for axis of symmetry. Let's see. So we're going to be talking about a vertical axis of symmetry. So vertical lines go which direction? Good. Vertical lines go up and down, which means in this case my parabola goes up or it goes down. Cool? All right. So the form is going to look a little bit different than what we've seen in the past. But truly it's not a big deal. It's a rearrangement of what I'm already used to. So just like before, the x minus h is squared. And it will equal 4 times p times a parenthesis of y minus k. This is a rearrangement of the standard form of a parabola. So don't think we pulled it out of the thin blue air. We just did some algebra on it to get this parenthesis squared by itself. Understand that. That's all we did, is we did some algebra to get this thing by itself. So just be aware of it. Okay, now remember, vertical axis means this is an up-down parabola. So one of the ways that I like to remember that this is an up or down parabola is the fact that the y is not squared. If y is not squared, then it goes either up or it goes down. Now, if you recall, the vertex of the parabola is the first thing we find. So the vertex is still going to be the x-coordinate first and the y-coordinate second. So it's going to be h, comma, k. Remember, these parentheses must both be equal to 0 to get the correct vertex. Just like the circle that we talked about before. Same thing. Cool? All right. Two new pieces of information for us. We have the focus. Now, I need you to understand, if you look back over here at the definition, do you notice the focus is actually inside the parabola? The focus is always inside the parabola. Make that note to yourself. The focus is always inside the parabola. So if this is a parabola that goes up or down and the focus is inside, that means the focus is either going up or it's going down, isn't it? Because the parabola goes up or the parabola goes down, which means the focus has to either go up or it has to go down to go inside of it. So it's the k coordinate that's going to change. And the k is going to be affected by adding this value of p, whatever that is. Now, some of you are like, yeah, but what happens if it goes down? Don't you subtract? If it's supposed to go down, this will work itself out. It will end up being a subtraction problem, so I'm not concerned about that, okay? Okay, now let's look at finding the directrix. So, the directrix is a line, isn't it? Notice, they called it a line in the definition, right? They called it a fixed line. They called it a line. If your parabola goes up or your parabola goes down, and notice this directrix is not intersecting this parabola at all. It's outside of it, agreed? But here's what I need you to understand. This is a horizontal line, right? Horizontal lines start with what variable? Good, y. Think about it. This is a parabola that either goes up or down. The y coordinate of the focus is being affected. The directrix is a y equals. Y is being affected for this whole thing. So y equals. Now, since the focus is inside, we added this value p, correct? Good. And I'm still talking about the y, which means I'm talking about the value of k, because k is my y. And since the focus is inside and we add, to get the directrix, we're going to subtract that value of p. Cool? Okay, hang in there. Let me, if you allow me, I'm going to do a little bit of erasing here because I want to write down the other parabola and the direction that it goes. So if I have a vertical axis of symmetry, then I'm also going to have a good horizontal axis of symmetry, aren't I? Okay, so horizontal goes which direction? Yeah, it goes left-right, doesn't it? So question, if it goes left-right, which variable am I talking about? Which variable goes left and right? Yeah, it's the x's. So in this case, now we're going to be talking about x's. So understand that. Are you with me? We're going to be talking about x's. So we have the horizontal axis of symmetry. And my equation is going to look a little bit different than here. The vertical axis of symmetry, y was not squared. Vertical means up, down. Y's go up, down. Horizontal axis of symmetry is in the direction of the x's. So now I'm talking about the x's, which means the x's will not be squared. So I'll have y minus k squared equals 4p times x minus h. Horizontal refers to x's. X's are not squared. Vertical refers to y's. The y's are not squared. Okay. Let's talk about the vertex. Vertex is not changing. It is still h comma k. X comma y. All right? The focus. Remember what I mentioned? The focus is always located where? Good, inside the parabola. So now I need you to picture a parabola that either goes left or right. And I don't care which direction you're looking. I'm just going to draw a parabola going that direction. And if this is my vertex, my focus is located inside, which means my focus would be located here, isn't it? So if my focus is inside, which coordinate is being affected? Yeah, the x is being affected because it's either going to go left or it's going to go right. So This is now going to be h plus p. The y is not affected. Got it? The x is being affected, so I'm adding to get inside. And the directrix, where is your directrix located? Yeah, the directrix is outside. And in this case, the directrix better be a vertical line because it cannot cut through the parabola at all. So it has to be a vertical line. And vertical lines start with what variable? That's right, they start with x. This should be no surprise. This is horizontal, which means it goes in the x direction. So my x's are being affected. And that would be h. And since this is outside, yep, you get to subtract h minus p. To get inside, you add the p value. To get outside, you subtract the p value. You with me? Okay, hang in there. Got some. Okay, so let's look at the set of directions here. They would like us to find the vertex, the focus, and the directrix, which implies we're dealing with a parabola, because a parabola has a vertex, a focus, and a directrix. Now, remember, we dealt with a circle in another lecture, and we knew we had a circle because x and y were both squared, weren't they? All right, in this particular problem, are both variables squared, or is there only one variable squared? Good, there's only one variable squared, which definitely tells you it's a parabola, not a circle, because a circle has x and y squared. This is a parabola. Now, notice, is it in standard form? Yes, it is. It's in standard form. Now, which variable is not squared? Yeah, x is not squared. X is not squared, which means this parabola goes either left or right. Got it? X is not squared, which means this either goes left or right, which means it's my x coordinate that's being affected the whole way through this problem. Got it? All right, what's the very first piece of information we find? Look back at how I wrote the standard forms. Good, the vertex. Because the vertex, once I know it, then that's the thing that moves, shall I say, to find the focus and the directrix. So vertex is important. It's the most important thing for us to find first. So what's my vertex in this case? Remember, the x has to go first and the y coordinate second. Good. Your vertex is a -2, 3. Got it. Good. X first, y second. All right. Now I need to find the focus, don't I? Because that was the next piece of information it asked me to find. Yeah, you're like, I need to find the focus, but I'm missing something. Yeah, you're missing that value for p, aren't you? By the way, some authors of the book call it the value of a instead of p. Just understand it's the same thing, okay? Everybody uses different variables, so don't get too hung up on the variables. All right, so to find the focus and even the directrix, I need to know the value for p. So, to find p, remember the standard form, and I'm going to rewrite it over here. It was y minus k, quantity squared, equals 4p times x minus h, right? Okay, p is right here in front of the x parenthesis in this case, correct? Well, do you notice what's in front of the x parenthesis in the problem? Yeah, a -20. A -20 is in place of not just the p, but the 4p, isn't it? Okay, which means in this case, I have -20 equaling 4p, which means p has the value of, excellent, -5. Good? So, that means to find the focus, remember which coordinate's moving? Good, the x, because the x is not squared, that means it's going left or right. So that means I'm going to have h, which is -2, and the focus is always inside, isn't it? So plus that value for p, and comma 3. Which means your focus is going to be at -7, 3. Cool? Remember, you add the value for P. This is the value for P. We add it to get to the focus. Good? Okay. So, they asked me for the vertex. Got it. They asked me for the focus. Got it. I still need to give them the directrix. So, let's look. So, the directrix. Remember, in this case, since this parabola goes either left or right, it either goes this way or it goes this way, your directrix will be what kind of line? Good, it'll be a vertical line because it cannot pass through your parabolas. So, vertical lines start with, they start with x. Remember, this is a parabola that's going left or right. The x is being affected. My x was affected to find the focus. My x is being affected to find the directrix. So what's my x? -2. And since the directrix is outside, you're going to subtract. And I'm going to subtract the value of P, which is -5. Which means we have x equaling 3. Because you add those, don't you? Right? Okay, directrix found. Check. How we doing? Okay, let me show you a visual of what you have just found here. Because I still need to know if this is going left or right. They're not asking me for that, but it's pretty good if I understand that. So, let's get a drawing down, because that will probably help us. So the one thing I know is my vertex is at -2, 3. So there's my vertex. And then the focus is at -7, 3, right? So I got to go -7 and 3. So there's my focus. And my directrix is at x equaling +3. So that's an x equals 3. That's your directrix. So, remember, the focus is always inside the parabola, isn't it? The directrix is always outside the parabola, isn't it? Which means in this particular case, your parabola is going which direction? Yeah, your parabola is going to the left to get the focus inside and the directrix outside. Now, some of you may be going, well, how can I tell if it goes left or right from the very start? Well, remember when we had the parabola, and if there was a negative in front of the x squared, it told me it flipped, it switched directions? Well, check this out. See that negative in front of that 20? That's telling me that it's going to switch to the left and not the right. Because the right is the positive side, the left is the negative side. Are y'all with me? Okay, so hang in there. Got enough. Okay, let's look at this one. The directions of the chain are the same. Find the vertex, the focus, and the directrix. Now, question. How many variables are squared here? Good, only one. So is that a circle or is that a parabola? Excellent, it's a parabola. Because circles have x and y squared. This has only one variable squared. Good. So since it's a parabola, remember, my train of thought goes, well, which variable is not squared? The y is not squared. So, y is not squared, which means this parabola is either going to go up or down. Now, some of you may remember it a different way. That's fine. Whatever works for you. This way works for me. So, first things first. Vertex is first. So in this particular case, my vertex. What's the x-coordinate? Good, +3. What's the y-coordinate? Good, -5. Got that covered. And now I need the focus and the directrix, don't I? But to find either one of them, I need this value of P, don't I? Okay, so to find P, remember, this one's, the standard form of this one was x minus h squared equaled 4p, and the parentheses of y minus k. Do you notice it's basically the same as the last problem? 4p is in front of that parenthesis of y. Well, look what's in front of my parenthesis. Yeah, 10, which means 10 must be equal to 4p. Looks like I'm getting a fraction. Well, so be it. If I get a fraction, I get a fraction. I'm not going to mess with it. Okay? Not going to fight it. Don't put it in a decimal because I didn't say anything about a decimal. I know some of you get decimal happy. It didn't say for a decimal. Leave it alone. Got it? Okay. So, vertex found. Focus I need to find next. So, to find the focus, since this is either going up or down, which coordinate's getting affected? Your y is getting affected, which means x will stay the same. And to the y, yeah, the focus is inside, isn't it? So since it's inside, you're going to add. And you're going to add the value of p, aren't you? Okay, so hopefully you remember how to add your fractions. You verify. I get a negative 5 over 2 when I add these. All right? Okay, so here's my focus. Got it. Directrix found. Pardon me. Vertex found. Check. Focus found. Check. One more thing to find. Yep. You still need to find the directrix. So, remember, this is a parabola either going up or down, isn't it? So since it either goes up or down, your directrix being outside means it's going to be what kind of line? Yeah, it's a horizontal line. And horizontal lines start with what variable? They start with y. Remember, this is the y not being squared tells me this is up or down. So the y coordinate is always being affected. And the y is negative 5. The directrix being outside means you're going to subtract. And you're going to subtract by that value of p, 5 over 2. Which means in this case the directrix is, good, negative 15 over 2. I'm going to let you verify and add your fractions together. Okay, so just found the directrix. Let's see what the graph of this looks like. Let's see if it makes any sense to us whatsoever. All right, so I am going to get my graph going here. And I have got the point 3 and negative 5. So vertex right there. Focus is at positive 3. And that's a negative 2.5, isn't it? So right about there is my focus. And my directrix is y equals, what is that? Like negative 7.5? So 7.5. So this looks like my directrix. Y equals negative 15 over 2. Okay, if you draw this, since the focus is inside, it has to go up. And how could you tell it was going to go up before you did your work? Aha! Some of you are like, wait, this 10 is positive. That tells me that it's going to go up. Because the positive direction for the y's is up. The negative direction for the y's is down. Good? Does this make sense? Okay, hang in there. Got some more examples. Okay, so let's look at this third example. Do you notice you have the y squared and the x is not squared? So, is this a circle or is this a parabola? Good, it's a parabola. Because a circle has both x and y being squared. A parabola has only one variable squared, and in this case it's the y. But is it in standard form? No, it's not, which means we need to get it in standard form. And the way we get it in standard form, remember, is to complete the square. So, complete the square says, if I'm going to complete it based on the y's, then everything else has got to move over. I need these y's by themselves so I can complete the square correctly. Good? Okay, so Now, there's no number in front of the y squared, or I should say there is a number, but it's a 1, which is exactly what we want, so we're good. So now it's time to complete the square. So I'm going to take the number in front of the y, I'm going to take half of it, and then I'll end up squaring it. So half of it will be a -6, squaring it will be a 36. With me? Which means my equation, I'm going to rewrite it a little bit. I'm going to add a 36 onto this side now, aren't I? And that's going to equal a -4x minus the 36, but now I'm adding 36. Agreed? All right. So, remember, the whole reason we did that was so that we could factor this side quite easily. So it factors, in this case, to y minus 6 times itself. And on the other side, I end up with just a -4x, because these 36's drop out. Cool? Okay, so is this in standard form? Yes, it is. Definitely a parabola. Now, this parabola is either going to go one of two directions. Remember what we said? Good. The x is not squared, right? Which means this is a parabola that's either going to go left or right. One of those two directions, either left or right, because the x is not squared. Cool? All right. We got to figure it out now. So the first thing to figure out is your vertex. What's my vertex in this case, please? Good. 0. Correct, because there's nothing added or subtracted to the x, comma 6 for the y. And now I need the focus. But to find the focus or the directrix, what do you need? Yeah, you need that value of p. So to find p, remember, that's right, it's this -4 I have to deal with. So 4p has got to be equal to that -4, which means in this case, p is equal to -1. Cool? Okay, so now your focus. Remember, since it's going either left or right, it's the x value that's changing, isn't it? So my vertex is 0, 6. And in this case, since you're looking for the focus, you go inside the parabola, so you're adding. And in this case, I'm adding a -1, which means my focus will be -1, 6. Now the directrix. So your directrix, remember, we're dealing with x's, correct? Yeah, so your directrix has to also be an x line. X had to be 0, and the directrix being outside the parabola means you have to subtract, don't you? So in this case, you're subtracting, that's right, the -1, which means your directrix x equals a +1. Cool? Does this make sense? Okay, I'm going to find myself a little bit of board space. Why? Because I want you to see what this graph looks like. So I am going to erase how we completed the square. Hopefully you're getting a little bit of graph paper out yourself, or using your notebook and writing it down nicely. So my vertex is at 0, 6, isn't it? All right, so let me get this drawn. So there's my vertex at 0, 6. Vertex. My focus was at -1, 6. My directrix was at x equals 1. So which direction is this parabola going? Yep, it's heading to the left. And you knew it should have been heading to the left because there was a negative in front, which means it looks something like this. Good? Cool. All right, hang in there. Got a few more examples for us. Okay, so let's look at this example. They're asking us to find the equation of a parabola given this information. Now, notice something. Because I have parabolas that go up and down, left and right. And based on this information, I need to figure out which direction it's going. So, notice something. I'm noticing the x values are changing, which means this parabola is either going left or right, which means we have a horizontal axis of symmetry. Are you with me? Okay, which means the standard equation of a parabola that's going left or right does not have the x's squared, which means the general format looks like, and hopefully you've written this down in your notes somewhere so you can follow along with how I wrote this. Good? Okay, so the equation we need to come up with needs to be something in that format. So we need to fill in the blanks. We need to find our puzzle pieces to fill this in correctly. And what we need to find is we need to find h, k, and that value for p. Because once I have those three, then I've got all the pieces to my puzzle and I can find the exact equation. So let's take a look. Did they give me h or k? Yeah, they did, because they happened to give me the vertex. And the vertex deals with h and k, doesn't it? So in this case, h is 0 and k is also 0, right? Because that's h and that's k. Agreed? Super. So I got 2 out of the 3 pieces. I need one more piece. I need to find the value for p, don't I? All right, so let's talk about that. This is what I'm trying to find. The one piece of information I haven't looked at yet is the focus. So, to find p, I'm going to look at the focus. And since the x's were doing the changing, I'm only going to look at the x value of the focus. The x value of the focus to find it was h, and remember the focus is inside, isn't it? So it'd be h plus p, wouldn't it? Okay, my x value is 3, my h value is 0, and then plus p, which tells me p is equal to 3. So now I have got my value for p. Ready to fill in all the puzzle pieces? Okay, here's my board space I'm going to work with. So, parentheses, y minus k squared equals 4 times p times the parentheses of x minus h. Good? Well, this would just be y squared, wouldn't it? This would be 12, and x minus 0, yeah, that's just x. So there's the equation of the parabola that has this piece, these 2 pieces of information. Cool? Hang in there. Got another problem for us. Okay, so let's look at this next example. The directions have not changed. They still want me to find an equation of a parabola, and this is the information they've given me. Now in this particular case, notice the y's are changing, which means this is a parabola that either goes up or down. And if it goes either up or down, then I have a vertical, because vertical lines go up and down, axis of symmetry. With me? Which means I need to know my standard equation of a parabola equation that goes up and down. So since the y's are changing and that goes up and down, that means the y value, or the y's, are not squared. So that means we have x minus h squared equal to 4p times parentheses y minus k. Good? And remember, we need the following information. In order to write this equation, we're going to need h, k, and the value for p. So, the question is, do we have any of those 3? We do. Good. Excellent. Because they gave me the vertex. So I have h and I have k. So h is good. K is good. And I still need the value of p, don't I? All right. So to find P. You know what we haven't looked at yet, right? You're right, we haven't looked at the focus. So, look at the focus. And it's the y that's changing, isn't it? Which means y has to be equal to k plus, because the focus is inside the parabola, the value of P. So, when I look at my focus, my y coordinate is -5. I know k. K was -3 plus P, which means it's easy to find the P in this case. Good? Okay, so I found that P was -2, which means time to write our equation. So the equation, generically speaking, looks like this. H was 3, so I have x minus 3 being squared. P was -2, so 4 times -2. And the parentheses of y minus k, and k is, good, -3. So, we end up with the parentheses of x minus 3 squared equals -8 times y plus 3. You with me? By the way, this negative in front, does that mean it goes up or down? That goes down. On the last problem, that 12 was positive, wasn't it? Which means the parabola went to the right on problem number 1 that we just did. This problem, this is negative, which means it's going to go down. Does this make sense? Is this cool? Okay, so hang in there. I got some applications.
Okay, so let's talk about some applications of the parabola. Let's look at this first example. We have a satellite dish in the shape of a paraboloid of revolution. The signal that emanates from a satellite strikes the surface of the dish and are reflected to a single point where the receiver is located. If the dish is 16 feet across at its opening and 5 feet deep at its center, at what position should the receiver be placed? Now, I don't know about you, but me personally, I'm going to draw myself a picture. And the very first sentence says they have a satellite dish that's shaped like a paraboloid of revolution. Now, you may not exactly know what that looks like, but paraboloid sounds like you're dealing with of course, a parabola. So we have this parabola and a signal that emanates from a satellite. So somewhere up here we have a satellite, right? It strikes the surface of the dish and it's reflected to a single point where the receiver is located. So this is our receiver. Now, they're telling us that the dish is 16 feet across at its opening. So we know this is 16 feet. And it's 5 feet deep at its center. So we know this is 5 feet. And they want to know what position should this receiver be placed. So let's go, and first off, I'm going to get myself a new screen. Why? Because I want to be able to do some work and draw better. So here's our parabola. Here's the receiver, correct? We know that this is 16 feet across the top. We know that at the deepest point from the center, or through the center, I should say, is 5 feet. Now, we clearly would have a parabola that would be facing up. Agreed? It's not going to face down, and it's not going to face sideways. Those are not very good representations or very good positions for a satellite. Now, since it's facing up, we know that the y value is not squared. And the reason I'm bringing that up is this. I am going to write myself the generic form of the parabola. Because more than likely, if I had an equation, then I could pretty much answer their question about where that receiver is located. And remember, this right here is the receiver. Got it? Okay, so since it's a parabola facing up, I know that the y is not squared. So I know my generic form of a parabola facing up will look like this. Now, h and k represent what? That's right, they're the vertex. Now, here's the deal. It's up to us where we want to place this particular parabola on the grid system. Because this whole equation is based on x's and y's and h's and k's, and that's a grid system. That's the Cartesian system. That's the xy plane. So I'm going to make life easy on myself. I am going to let my vertex be at the origin. This is where I'm going to let my vertex be. I'm going to place this parabola so that my vertex is at the origin. It's your choice where you want to put the vertex. I'm going to make life easy on myself. So if I choose the vertex to be at the origin, then my equation is going to look like x squared equals 4p times k. Whoops, sorry, not k, y. Because k was 0. You with me? Now some of you may be going, yeah, but if I move the vertex into another location, if I make it be a different point, that's fine. You can make it be a different point. Gratefully, we're going to come up with the same answer. Cool? Okay, but again, let's work smart, not hard. Now, something I need to ask you all. That receiver, I know where it's located. It's located through that center, isn't it? Question for you. Since I'm dealing with a parabola, and I've identified this as my vertex, what would the receiver be? Yes, I think I heard some of you say it. Your receiver is actually the focus. So here's the deal. In order to find the focus, I need the value of P, don't I? So to find the focus, find value of P. So here's the deal. If I knew X and I knew Y, I could find the value of P, couldn't I? All right, so let's take a look at our picture again. Can I find a point? Can I find an XY? Well, as a matter of fact, I can. Notice it's 16 feet across, isn't it? Which means from the center to this edge of this satellite dish, this parabola, is actually how far across. Good. This would be 8 feet. So, since that's going to the right, I know that the x would be 8. Now, we also know that the dish is 5 feet deep, don't we? Which means that would be the height of the dish, right up to the top. Agreed? Well, then I know that my y value is 5. Make sense? So I do have a x and a y. I have the point 8,5. And so if I plug in the point 8,5, let's see, and I'm going to bring this up over here so I have more room. I end up with P equaling 64 over 20, which means P would equal, let's just reduce the fraction, 16 fifths. Got it? Okay, so now, the whole reason we did this was to find the focus. So, the focus, remember, it's going to be x, pardon me, it's going to be h, comma, k plus p, because the focus is inside the parabola, remember? So you add to get inside. Well, I know h. H is 0. I know k. K is 0. And now I know the p value, which is 16 fifths. So my focus is at the point 0, 16 fifths. Now I'm going to look back. And it's asking the receiver should be placed how many feet from the base of the dish along the axis of symmetry. And notice it says it wants an exact answer. Exact answer means no calculator, so stay off of those things. So the receiver should be placed how many feet from the base of the dish? So what we found, it was 0, 16 fifths, right? Therefore, the receiver should be placed 16 fifths feet from the base of the dish. And it said along the axis of symmetry. So, and even though they're not asking for this, just for us visual people, so that's 3 1/5 feet from the base of the dish. So it's a little over 3 feet high, right? But they didn't even ask for a mixed number. So I need to give them the final answer of 16/5 feet. Cool? Okay. So let's look at this next example. It says the cables of the suspension bridge are in the shape of a parabola as shown in this figure. The towers supporting the cable are 700 feet apart and 100 feet high. If the cables touch the road surface midway between the towers, what is the height of the cable at a point 175 feet from the center of the bridge? So, since we have a parabola and it is facing up, then I know the y is not squared, is it? So, this tells me my equation that I'm going to be dealing with looks just like this one. I am going to get myself some more working room. So, I'm going to draw myself the grid system. Okay? And on this grid system, I have the choice of where to put this bridge, which is in the shape of a parabola. So I am going to put the vertex at 0, 0, because that's going to be the easiest thing for us to do, right? Okay, now if we go back and take a look, the bridge between the two towers is 750 feet, isn't it? So if I'm looking from the center of the bridge out to one of the towers, how far across is that? Excellent. That's 350 feet. So I know from here to here is 350 feet, don't I? Good. They also told us that the bridge happens to be 100 feet high, which means from here to here is 100 feet, isn't it? So you can pretty much guess I'm going to have this point over here that's 350 feet across and 100 feet high. Do you agree? Okay, so let me get my equation back again. All right, my equation is looking like, again, since it's an up-down parabola, the y is not squared. Do you agree? And since we put the vertex at 0, 0, that means, and let me just rewrite it so we can see it. Since the vertex is at 0, 0, that means that your equation of this parabola is going to look like x squared equals 4p times y. Y'all with me? Okay, so let's come up with the equation for this particular parabola, shall we? The one thing I don't have is this value for p. If I need an equation, I need the value for p in order to help me out. So, to find the value of p, I need to know an x and a y to help me find the value of p. Do we have an x and a y? Yes, we do. We have that point 350, 100, don't we? Which means our equation is going to look like 350 squared equaling 4 times p times 100, right? Okay, so remember, we have to keep things exact. So we have 350 squared, and some of you already got your calculators out working on this. This is what I have, equals 400 times p. So we're working on just the arithmetic part, shall I say. Got to reduce, and let's see if this goes in evenly. This does not go in evenly. Let's take a gander. They didn't say anything about a decimal, so I can't use a decimal. Got it? All right. So I know that the value of p is at least going to be equal to 1,225 divided by 4, right? And that means our equation looks like x squared equals 4 times p divided by 4 times y. Gratefully, those 4's drop, don't they? Okay, so here is the equation of our parabola. Again, to answer these questions, if I knew the equation of the parabola, I could actually help myself out, which is why whenever they give you these type of problems, you always want to find that equation of the parabola in order to answer any other question they may have. So now that I have the equation, I can start looking at the question again. The question was what? It said, if the cables touch the road surface midway between the towers, they want to know the height of the cable at a point 175 feet from the center of the bridge. They want to know this height right here at 175 feet across, don't they? Well, at 175 feet, isn't that a value of x? And they want to know the height, which is a value of y, isn't it? So technically that point would be 175 comma y. Agreed? All right, which means to find the height, we have to find the value of y, don't we? And the point we're working with is 175 comma y. So let's plug it in to our equation and see what it's going to give us. And again, it said nothing about a decimal, so you can't give them a decimal answer. All right? Okay, so this is what I get when I square this. Boy, am I hoping this divides nicely by 1,225. And for me it did. I got y was equal to 25, which means at that point, this is 25 feet high. At 175 feet from the center. Cool? Awesome. I'm just curious. Did any of you think that that would have been 50 feet high? And if you said yes, I can understand why you would have thought that. Because some of you are thinking, well, 175 is half of 350. And if 350 feet across is 100 feet high, then shouldn't half of it be 50 feet high? Well, no, not really, because you're talking about a parabola. You're not talking about a line that moves in an upward direction at the same pace, because that's slope. Slope is at a same pace. It would have had to have done this. That's not what our graph is doing. Our graph is doing this slow rise up. All right, so be careful about assuming things like that. Okay, so hopefully this makes sense to you. You guys have fun with parabolas, and I'll catch you on the flip side.